Monterey. It's basically our kind of solution to trying to manage security in the cloud. Before we get started with that, I'm going to talk about myself a little bit. So again, my name is Kevin Glisson. I'm a cloud security engineer at Netflix. At Netflix, I have the opportunity to work on all different kinds of security automation, everything from SSL to our PCI compliance and hacking away at the AWS endpoints. I'm a lover of all things Python and AngularJS, so if you guys have any cool tips or libraries, I'd love to hear about them. Previously, I've worked at JPMorgan Chase, first as an incident responder, and then as a cyber intel analyst. About Netflix. As many of you know, Netflix is doing quite well. We have a lot of customers these days, and we push a lot of bits downstream to all the different customers. In order to kind of deliver that service to people, it takes a lot of applications to deliver that service, deliver those features, deliver those recommendations, and kind of enjoy it every day. A little about Netflix culture. So Netflix culture is a little different than what you might be used to. When you think about Netflix's culture, we really try to focus on developer enablement. And so what does that mean? We really take it to heart to enable our developers to make decisions and give them the power and the freedoms to do that. What that means is that we give them those permissions. They're able to push code. They're able to make decisions about certain pieces of infrastructure. And that really goes into our idea of what development operations really is. For those of you who may not be familiar with developer operations or DevOps, it's really about an engineering team or an engineer owning their whole application end to end. When you think about traditional kind of segmentation in a kind of technology technology development lifecycle, you can kind of think of a developer writing code. He takes that code, he hands it off to some build engineers who then build it and package it, who then hands it off to deployment engineers to get that code running on instances. And then once that's kind of completed, you would then have a monitoring team or operations team that would make sure that uptime is correctly going, that there's no issues, that everything is running as it should. When a developer owns the whole stream from end to end, we feel that provides them with the best context. So they know what metrics they should look at to determine whether or not their application's up and healthy. They know how best to package their application. And we really focus on enabling that whole life cycle and giving those application developers context so that they can do and iterate and create new features as quickly as possible. I want to just take a moment here and go a little bit into how Netflix kind of takes this to heart, how we automate a lot of our processes around this kind of sense of enablement for our developers. So it really starts with, you can think of, it really starts with a piece of code. That code's maintained and versioned in something as a source code like Git. And once that developer feels that this is something I want to test, this is something I want to try out, they'll then have Jenkins build that piece of code into a package for them. Once that package is kind of created, it can kind of be targeted to a Debian or an RPM, depending on what your target OS is. That package is taken and baked. So what do I mean by baking? So every different thing we do, every different deployment we do, creates an image. And the way we create those images is we take base AMI, which is really your OS, and we install your packages and that package's dependencies onto that image. From then on, that image never changes. It's kind of an idea of an immutable server. So when you think about making changes, this process will always happen every time. This is for bug fixes, for new features. Anything that requires changes to the OS system will create a new image. And this way, we can kind of maintain an immutable server model. That model enables us to ensure that regardless of how many instances we deploy, if it would be hundreds or thousands, each of those are the same, and we can have uniformity across those instances. You may be familiar with kind of the idea of using Chef or a Puppet to go and actually patch systems. And we believe that that can cause disparity between your different fleets and makes debugging particularly hard. So you got to think about every time we do something new, we create these images that can be easily rolled back to, and we know that their state is what we think they are, and they're not in some weird state. So once those images are kind of created, we'll use additional tools like Asgard to actually go ahead and deploy those to the different regions. So if you're familiar with AWS at all, you kind of know that inside of AWS, there's these things called auto-scaling groups, or ASGs, and each one of the instances within the ASGs are kind of created off of this base image. So in this way, we leverage existing systems and tools we've built to create this chain to go from all the way to code to running system that's largely hands-off from the developer. Once it's configured, this will happen continuously when the developer wants to, and the process is very, very repeatable and reliable, and allows us to manage our systems in a lot of different regions and a lot of different environments. So you may be thinking, well, that's nice. What else can you tell me about Netflix's environment that makes it kind of unique? So we're almost 99% in the cloud. We have tens of thousands of instances in AWS. An interesting thing, when you think about it, it makes a lot of sense, but evening times, our peak times, doubles our instance counts. When you think about going home, you think about coming home after work and you just want to switch on Netflix, all those people, we really, really rely on Amazon's ability to grow with us in our load. And along with those different 100 applications I mentioned earlier, we also have dozens of versions of each of those applications. So Netflix believes very strongly in doing a lot of tests. So they want to make sure they're constantly innovating, constantly adding new features. And the way they accomplish and measure whether or not those tests are successful is doing something called an A/B test. So if any of you aren't familiar with an A/B test, it's this notion of you have some code, you have some features that are running, and you want to measure a new feature, a new type of workflow, something that the user interacts with, to see if that drives new or more watching or better quality watching or more happiness from our customers. So what a developer will do typically is take his new feature, deploy it through the pipeline that I just kind of went over, and then take a portion of the traffic that the full site is currently receiving and point it at the test. And then he'll use some metrics to determine whether that test is successful. And what this means is that not only do we have hundreds of different applications kind of serving this experience to our customers, but each of those services have different source code running at the same time. And all this kind of goes into why we developed Project Monterey. So when you think about this environment, you think about all these things happening, you think about all the different versions of code and all the dynamicism that is DevOps, right? So if you let developers push code at any time, you let them create infrastructure, delete infrastructure, you think about what all that dynamicism means and how you kind of get a handle on it. Because of the nature and the freedom we give our developers, there aren't a lot of good places to inject traditional security checks. There's not a way to be able to say, hey, that you have a new release coming up, let's do a security check to make sure before you push that out live that everything's okay. So Monterey was really intended to be a part of this whole ecosystem of automation. Do you have a question? Yeah. No, so we have a centralized team, and we basically handle it for the whole company. So when you think about how you kind of manage all this chaos of things coming down, there's different versions, you really need a good way to integrate. You have your automated kind of development and build process, and you also need to kind of think about, okay, well, how do I automate and develop a security process around that? We can't really inject these gateways or traditional kind of checkpoints to slow down a developer and give us an okay. This is a real nice kind of 10-second summary. It's got a lot of buzzwords in it, but what Monterey really is at its core is just a framework. And this framework enables us to hook into the different services and pieces of context that we can gather throughout our environment to give our security application engineers as much context as possible. Our main goals with Monterey is to make it very, very easy to use. So as we develop new sources of information, we bring on new tools, we want to be able to take those tools and take that pieces of information, put it through a kind of pipeline of security events, and then continue on with managing how you scale that up, how you make sure that those tools, even though they're not written necessarily to be handled and handle thousands of scans at one time, they can still accomplish that goal within our environment. It is Python based, and it's fairly easy. We've made it we've made a very big point in making it as easy as possible for security engineers who, or security application engineers who are used to pen testing, used to kind of hacking on stuff, to make it as easy as possible for them to write their own scripts and then basically be able to push those scripts out to our whole environment. So a basic Monterey overview can really be broken down into 4 different parts. The first one we have is this idea of discovery. When you think about things coming up, you think about developers changing things, think about different security groups or permissions being changed at all times. Discovery gives us a way to go out and search and develop what the context of our environment is. So we really want to be able to dynamically go out and look, say, well, how many ELBs do we have open at any one time? How many instances are open to the internet through the security groups? We want to be able to do that dynamically. And discovery kind of portion of Monterey allows us to do that dynamically. And not only do that dynamically, but use sources of information from our other security tools or security and infrastructure tools to give additional context and allow Monterey to take actions when it needs to. The second part of it can really be thought of taking that discovery information, and even if it is so dynamic, you still want to be able to track some of that information over time. So if you think about a specific application, you may be able to want to see, okay, well, I've scanned this with a particular scanner, and I want to make sure I want to see when's the last time I scanned it, maybe for auditing purposes. You want to see how many times have I scanned this in the last month. All these type of things that really you want to be able to track the application through its kind of security state. So you always want to be constantly developing that security state and identifying what is it about the application that makes it sensitive. Maybe there's additional things we want to do because it is a sensitive application. The third part is really about developing security context. So if you think about discovery trying to derive information from our environment, you can think of scanning as to actually take that information that we've derived from our environment and actually applying security tools that we all know and driving security context out of those. So typically that can be tools such as ZAP, Arachni, or Nmap that allows us to take the information we've kind of discovered about our environment and do some specific security testing on those things that we do find, and then take that information and leverage it into our third or fourth kind of overview section here is results. In results, we really take all the information you can kind of think of as a big downstream effect, and we make sure we correlate that information as much as possible to give the security engineer as much context as he can. So at this point, when he's looking at the results, he has information about, okay, what was the environment looking like at any one time? What is this application that I'm looking at? What was its security state at the time that this was scanned? And what does that mean for me as a security engineer about what I'm going to do next? So what action am I going to take? Am I going to kick off a manual assessment of that particular application because I know it was open to the internet when it shouldn't have been, so I want to see what the impact is there. And it really drives what we do as next steps as far as focusing the limited resources we do have and improving our security state as much as possible. So how do we accomplish this? Traditional tools, you think about a ZAP, you think about that GUI that kind of pops up, you think about how a traditional assessment might go, and they might pick an application and work on that for a couple months and create a report, and then a developer would essentially fix whatever bugs they found in that report. But when you think about how often we need to do these, how many times we need to do it, the velocity and the dynamicism of all these developers pushing code in different versions and taking versions down, that's not really possible for us to scale that way. So the way we kind of scale these tasks is to develop this thing called a monklet. And a monklet, essentially at its core, is just, you can think of it kind of like a soldier, right? Has his orders, accomplishes his orders, tells his commanders whether it succeeded or failed. They don't have any state. They don't have any awareness of where they are as opposed to other monklets or other jobs that are maybe executing at the same time. And this allows them to be scaled as much as possible. When you think about your traditional just worker queue relationship here, there's nothing crazy, nothing revolutionary about this. But it allows us to take these tools that were once part of this manual assessment process, this kind of very, very singular approach, and scan them and scale them out to as many different nodes as we need. And I'd also like to mention that these monklets are used throughout Monterey. So they're used from everything from gathering discovery information, gathering information about our environment. They're used in scanning, so leveraging third-party tools to get that security state about our environment. They're also used in the result kind of function, right? So maybe we need to do some transform of some data of a report to feed another downstream tool. Monklets are involved very part of every part of Monterey. So I mentioned a little bit about third-party tools, and I just wanted to kind of reiterate what this provides for us. So we're very, very open to, we don't want to have any vendor lock-in, or we don't want to be tied to any particular application. We found that there's always new different tools coming up. There's tools that are very good at what they do, and we want to be able to integrate them as easily and as quickly as possible so that we can get that benefit from those tools enhancements, right? So our ability to be very loosely coupled with these vendor tools allows us to be tool agnostic, leverage the best tools for any given tool set, and use both upstream and downstream tools. I mentioned tools like going out and grabbing discovery data. So if a new tool came along that pulled some really, really interesting information from AWS, we could quickly leverage that to get that information into our downstream tools. And it really accomplishes the security heavy lifting. Monterey was never intended to create its own scan engine. It was never really intended to create security tools in itself. We really wanted to just take existing things and automate them in such a way that we can actually leverage and provide value to our downstream kind of security information guys. So of course, I mentioned third-party tools are very important, but it's also very important to realize that it's very, very easy to write your own kind of your monklet and be able to take that little piece of code, use all the infrastructure that Monterey provides, all that information from upstream tools and discovery method, and leverage that in a very simple way and a very scalable way that we can do. So I mentioned a couple different monklets that we've created that are very, very simple, that don't do anything special. But they've all been created in response to something we've actually seen in the environment. So, there's always type of this kind of reactionary thing where it was like, okay, well, we get this vulnerability report. We see that this is an issue. The first thing we always think about is like, okay, well, if this is an issue on this site, chances are it's an issue on other sites, right? So we want to make sure we establish kind of our baseline of where else we could be vulnerable to this specific thing. And in addition to that, we want to be able to continually check for that. So if you think about, we see a vulnerability, chances are it's somewhere else, chances are it could come back. And we want to make sure that that doesn't happen. And then if it does, we're alerted as quickly as possible so we can go ahead and fix that. The first one here, just a little explanation of what these things do. Response Grabber is very simple, kind of give it a URL, go to server, just check the response of it. Right? So we're looking for things in the body, maybe open cores, maybe paths that shouldn't be accessible from the internet. All these things can be checked very quickly, and are things that are very useful for us to give us a security state or things we're concerned about, but it's not something you would typically find in a big scanner. Or if it does, it would take a lot of resources. An ELB endpoints is a kind of example of a discovery monklet. And this basically just goes out and queries all of our ELBs, but it does so in all of our different accounts. So it's very important to us to be very flexible when it comes to gathering this information from all of our AWS accounts and really get a holistic view of all of our different environments. And then Verb Checker is similar to Response Grabber, except for that it'll actually go out and try different HTTP posts that we're worried about. So it'll go out and try different things on these endpoints that maybe shouldn't be allowed. Maybe we shouldn't be allowing delete on these specific endpoints. And it gives us a very quick overview and allows us to check continuously for these particular things that we care about. So that's nice. And I want to go over some real rock-solid examples of how we use Monterey to take information about our environment, to leverage that, provide additional security context, and then use that information to direct our team to think about what we should be looking at next. So if you guys aren't familiar with some of our open source tools, we have a tool called Asgard. And it basically allows us to manage our applications in the cloud. It'll set up auto-scaling rules. It'll set up new ASGs. It'll do deployments for us in an automated fashion. And it's a really good source for us to discover, okay, well, what applications are currently deployed in our infrastructure. All of our applications are deployed with Asgard, and so it's a good source for identifying, okay, well, I need to worry about these specific applications, and a good starting point. And we also query AWS to get information about those applications. So when you think about, okay, I have an application, I have a security group attached to the application, what does that mean? So is that application accessible from the internet? If so, we should take all those subset of applications that are accessible and go ahead and fingerprint them with an Nmap scan. Determine which ports they're listening on. Are there any new ports that have been exposed inadvertently? And if there are ports that we know and care about, we can go ahead and do a deeper dive into the application by using a scanner such as Arachni or Zap or any other web application scanners to get additional security information about that particular application. And once the scan finishes, we'll then upload results to an open source project called ThreadFix. And ThreadFix really allows us to track and particular assets vulnerabilities over time. So what it allows us to do is determine things like trends. So is this application, does it have more vulnerabilities over time, or are we driving down that vulnerability count? Do we see applications that or do we see vulnerabilities that used to exist, we fixed, do they come back? And this allows us to kind of understand at a very, very high level view if we see more and more regressions or more vulnerabilities in applications, maybe we need to address, talk to that development team, do some more education around maybe something more systematic in their development process that we can kind of head off and fix. So that's very important to us. So this is nice. This is something you could do on a scheduled basis or daily basis or an hourly basis. But if you think about what I mentioned earlier about all these applications, they're all coming up and down. There's all very, very different versions of them. It's really not quick enough. So what we do is we try to use the environment, use the chaos that all our tools provide and all the developers provide, and use it to our advantage. We have a tool internally called Kronos. And you kind of think of Kronos like a large bulletin board. Important applications, important development or deployment applications will all write messages to this bulletin board that anybody can see. And when we see something like a newly deployed application that Asgard has alerted us to the fact, we can go ahead and take an action. So we see something happen, change in our environment, we're aware of it, we can go ahead and take an action for to go ahead and do our scan, do our basic endpoint of that application. This is particularly useful when you think about when developers are creating tests. They're creating new versions of their applications they're pointing a small subset of traffic to those applications. And we can recognize that. We can go ahead and do a security scan. We can identify things before that application receives full load. So say that test was successful, that developer decides to go ahead and increase that load to the full bounce. If we can determine something in the testing phase, we can make sure that the large majority of our traffic never sees that vulnerability. And that's really what we're looking for, right? So we're really trying to drive down the response time as low as possible because we don't have those traditional checkpoints. All we have is really the response time that it takes when you see an application comes up and a vulnerability exists, how quickly do we respond to it, right? You can think about this in many ways as what attackers would do, right? So we're kind of trying to do it to ourselves. It's kind of in the same philosophy of you guys have ever heard of we have this notion of a simian army, right? Basically goes into our environment and messes stuff up because we know that in the real world stuff gets messed up anyway. So we want to be prepared for it. So we want to induce this on ourselves. And Monterey runs really, really in line with that, and it allows us to kind of run these actions that somebody else is going to do anyways on our infrastructure before they get a chance to do it. And we can do it faster than them. We can do it. We can get that fixed quicker than they can identify it. So after we've identified this new application, of course, we're going to upload those results into ThreadVix, do our correlation, and then notify us and maybe in the application owner about a regression if we do find something, or we find something new. I want to talk a little bit about Monterey's roadmap. Monterey is very, it's fairly full-featured. We're using it successfully internally in Netflix. We still have some work to do being efficient with our scaling. Currently, if you think about a normal web traffic server, you have a very, very, typically very regular kind of trend line as far as traffic goes, right? So you'll think about, so maybe you get your website gets more traffic in the evening, that traffic builds and loads and kind of goes in a nice big sine wave. Unfortunately for us, all the auto-scaling metrics and features are kind of built for that use case. And because every monklet is vastly different from each other, you have a ZAP monklet that can run for several hours. You can have a response grabber that's doing something very simple, like going out and fetching requests and do thousands a second. That logic doesn't allow us to scale as efficiently as we'd like. And so the current idea, the current approach is to take that kind of auto-scaling knowledge and build that right into the monklet itself so it can self-describe what resources it's going to need and allow Monterey to facilitate that resource management for it because chances are it knows best what it's going to, how long a scan's going to take of it, how many it can handle at any one time. All these things are really, really available to the monklet itself. And we're always looking for new workflows and use cases. I went through a couple short examples of how we kind of chain together these different building blocks or Lego pieces, if you can think about them like that. And we're always looking for new and interesting ways to kind of combine that data, try to find new sources of interesting environmental data. So as Amazon introduces new services, introduces new metrics, we're always looking to kind of use that data and leverage it to provide as much context as possible to the downstream security engineer. So we're always working on that. And we're always looking for new tools. We're always looking for new tools that can be integrated into monklets to provide security state that can do a cool correlation or something that just increases the value of all this information that we're collecting. And then, of course, we do plan to open source it. It's not quite ready yet, but we think that this kind of framework, these kind of building blocks, this kind of approach to being able to react to your environment, react to what's going on with your applications is general enough, and the framework is general enough that it could be useful to just about any organization. You may not need some of the scaling size, or you might not see some of those features, but that idea of being able to dynamically react to your environment, use that information, and leverage it we think could be valuable to just about anybody. And we love to get people involved with writing cool monklets, writing cool workflows, identifying different things that are really useful for them. So takeaways. So I want to take a talk a little bit here and say, when you think about traditional kind of security SDLC, it doesn't really apply to DevOps. You have developers with these freedoms to create infrastructure, to remove infrastructure, to make changes to their applications at will. You don't have release windows. And you don't have these traditional checkpoints that you might otherwise have in that kind of traditional life cycle. And because of that, you really need to start thinking differently about how you start to approach security in that mind. We're very much more of a consulting service. We very much will want to, kind of educate developers, provide a guardrail instead of a roadblock or a gateway. And we really want to work with them to enable them to build secure applications. So it's very much around this idea of you have this very, very automated kind of deployment process. Your security tools really need to scale with that. They really need to be integrated. They really need to be a living part of this beast. If you can think about just another organ in this whole machinery of how your organization kind of works. And then another key takeaway is current security tools aren't really built with this kind of scale in mind. They're very much focused towards like a pen testing type of workflow where you have assessments. You kind of go through your manual kind of environment. And they're not really built to kind of accomplish this baseline security scale with as many applications as we're kind of focusing with. And I want to make sure that emphasize that Monterey is not intended to ever replace manual penetration testing. It's really, really trying to provide value and context to our application security testers so they know what's actually been done on this application. They know some very baseline security state of the application and take that information and context and allows them to focus on individual applications that may be hurting, may be very, very, that may be accessible to the web, that may be have a history of vulnerabilities, and allow them to focus their energy and really use Monterey as kind of like a force multiplier when it comes to security. And just give them a centralized place for all this kind of context that they can then use to make the ultimate decisions about what they want to focus on. And I also want to kind of take a mention here. It's not on the slides or anything, but we feel very strongly about creating or building tools and supporting tools that help you create a solution. So if you think about a lot of paid-for vendor kind of solutions, they're trying to sell you something that fits all of your use cases. We found through the development of Monterey and our kind of approach why we took this road is that you're never really going to be able to establish a solution. You're never really going to be able to buy that. There's always going to be customization aspect. And we found it very valuable to invest in tooling that helps you create a solution as opposed to buying a solution outright. And Monterey has been really built with that kind of idea in mind that we want to enable security to be as prevalent and as automated as possible and allow it to be as loosely coupled as possible so that as our environment changes, as new tools are created, as new techniques are discovered, we can leverage Monterey and not be locked into that kind of life cycle kind of deployment things. Let's see. So I want to pitch right here. So our team is hiring. So if you think taking these challenges and some of the things we face with a large kind of cloud deployment, you think that's interesting, make sure you get in touch. I want to make sure you check out Netflix open source. We've had a number of cool security tools released lately. One called Security Monkey and one called Sketchy, among others, that really kind of show what we're trying to do as far as putting these tools out there, enabling people to build security into their kind of operations or just build it into their life cycles when you are tackling an environment like Amazon, tackling an environment where developers have a lot of freedoms and there's a lot of changes. So make sure you check those out. And I think we have some time for questions if we have any. Yeah. So there is no, the question is, there's a tool called SecurityMonkey that we've open sourced, and the question was around how do those integrate together? And they don't at the moment. Potentially we can use SecurityMonkey as just another source of data, right? So SecurityMonkey, if you guys aren't familiar, basically applies these rule sets against our infrastructure to alert on bad things like users that have INAM keys, that don't have two-factor authentication, security groups that are open to the world, right? So we can take that information and leverage it as a discovery thing and maybe make additional actions from Monterey, right? So if we see security change in SecurityMonkey, we can then take that new information about that environmental change and kick off a scan against that application, right? Because now that's open to the internet. And now that we want to know what our potential exposure is. So we haven't done that, but that's a great idea to go ahead and actually leverage that information in SecurityMonkey to kind of take additional actions about our infrastructure. Yeah. So of course, we would love to be able to make this as self-serve as possible to make the developers kind of use Monterey just as they would any other development tool. The current kind of theory is that it's still very, very too mature for that. And when you think about switching from a developer who just needs to write his code to a developer who needs to write his code and then kind of understand the whole deployment process and monitoring, giving them additional load to have to be a security expert doesn't make sense at the moment. So what our team does is we handle the information output on Monterey, and then we act as a consultancy to the teams themselves to say, hey, we've noticed the vulnerability. This is some steps to remediate. If they have additional questions, of course, they can come to us. And if there's, if we think there's more systematic kind of issues there, we'll go and actually do additional testing, additional like white box testing on that application to help them kind of get through that process.
It sounds like a lot's dependent upon your monk list and whatnot.
Yep.
And those are statements, but I mean, is there curriculum capabilities in there for monk list?
Yes. So I may have gone over that a little too close. If you think about that, let's see here. So you think about these kind of steps. Each of these steps, the results from one are poured into the subsequent monk list. So you can chain them together, and you can kind of establish this whole workflow. Alternatively, there's no reason why you can't have two monklets run at the same time. So if you have, 5 different things you want to look for, you can tell them to run at the same time, and Monterey will handle that no problem. But it is a really important part that you can chain these together. You can use information from Kronos or from one of our discovery services, take that information it's just got, and use it to actually dynamically kind of figure out what the security state is of the application. Any other questions? Yes. So yeah. So I think this is one part of our security process. We don't, obviously we have static analysis. We have some of those traditional things that, we just don't, the key part to take away is we do other layers of the onion of security, kind of trying to figure out, okay, well, what are the bugs, what are the security common vulnerabilities in our static code? What we don't do is basically prevent an application from deploying before we give it an okay. And this is trying to basically increase our response time to such expedience that that kind of limits, it allows the developer to continue to innovate, to continue to roll out, but it also gives us coverage that we can find it quicker than the bad guys. Yeah. Yeah, so if it's something, so because we do this continually, and because we have this immutable service kind of architecture, if we do discover something that critical, there's no reason why we can't reach out to developers and say, hey, roll back to your last instance, right? So if we see something come up, we scan it, we say this is really bad, reach out to them directly and redeploy through our automated build process within minutes or however long it takes to turn off all those instances or not. Does that answer your question a little better? Okay. Any others? Yeah. Yes. I don't know the exact date, but it's a lot. They're all stored in S3. We tend to keep them around forever until we decide that we don't need them anymore. I don't know. I'd have to ask the engineering tools team how long they're actually kept along. But there's a significant amount of version. I think they keep at least last like 20 or so. That's like anecdotal though, so I don't really know. Yeah. Yes. So I want to kind of reiterate that this is very much kind of a process that we deploy to kind of cover our bases, right? So it's never going to replace something that an automation tool can't cover. But what it does give us is it gives us kind of a baseline security state of the application, and also gives the security engineer who could do the actual manual assessment and find those things all the context of that application in a kind of easier method to digest. So they don't have to go out and actually figure out like, okay, well, what the security groups is this application deployed with? What kind of permissions does it have? All that's kind of provided for them, and that gives them kind of a speedier kind of loading into the whole when they do their actual testing. Yes, it's very much a complementary tool to that. It's really trying to drive where we should focus our manual testing and provide that context to the security engineer. So it's a very much complementary tool. Yeah.
Do you make frameworks that can scan in the image? Let's say like a heart bleed type situation, you want to see if you're at the red version of that.
Yeah. So you could definitely do that. You could definitely just have a monklet, and Kronos could alert you that a new package or AMI has been created. Go ahead and kick a monklet off to scan that AMI for a particular type of version you're looking for, any type like that. There's no reason the framework is jerk enough to definitely support that kind of use case. It's really about.
Would like put an SSH into the how it would work, or how would you check it's not discoverable to the Amazon API?
Well, so you can scan base. That's one way you could basically launch it in kind of a contained environment, and you could actually go and SSH into it. I believe we've created something, not super familiar. One of my coworkers did it, but we do have something to actually go ahead and check the versions of like the SSL for on our base AMIs, and ensure that throughout our fleet that we're not vulnerable. We don't have that vulnerable version of SSL in any of our running instances. Kind of thing. Yeah. Mm-hmm. So because we are able to kind of create as many of these scans as possible, what we want to do basically is run a lot of different web application scanners, and then use something like ThreadFix that ingests reports from all those different applications and see where they overlap. Because chances are, if you see 2 application scanners discover the same thing, the false positive rate on those kinds of drops. And because we're able to do as many of these as possible, it's not a manual process anymore. We can do that and provide additional confidence that these are actually vulnerabilities that we need to go ahead and address. Yeah. It's both. So this is a lot of these monklets are actually very focused on doing web applications, but there are monklets in addition that we've written that can go ahead and make sure check post delete on these API services that aren't necessarily going to try and crawl this web application, but they're still going to do some testing that we can actually do against an API. We don't have an automated process way to do that. We could definitely try to look into maybe figuring out a discovery monklet to tell if something's an API or not. That'd be kind of cool to kind of discover. We don't have anything right now to discover that in itself. But via inventory, we can kind of add additional like out-of-band context that, hey, this isn't a web application, this is an API, and you need to take the appropriate actions. In the same way that the inventory system allows us kind of to make sure we whitelist applications that through discovery may be part of this kind of whole system, but we really don't want to scan for maybe their third-party resources or something that we're not really permitted to scan. Any other questions? Yeah. Mm-hmm. Yeah, so you're just thinking, like, from the developer's point of view, how do they feel about fixing a bug that's kind of discovered? I think when you think about all the tools we've kind of done around enablement, I think from a developer point of view, you would want to feel really good about the fact that I'm obviously going to try to be secure, but if something else happens to get through, I know my security team is going to go ahead and have my back, kind of thing, right? So it really takes away some of the fear that the developer could have, be like, oh, well, I don't want to make these changes because I don't want to potentially expose or do something that's going to be bad. And it really gives them a sense of security that say, I'm going to try to do it right first, obviously, but I also know that there's going to be a checks and bounds against what I do, and then they'll come and get me. Because the process is so iterative, we don't really notice, right? So there's no waterfall model. There's no like, okay, well, we have to go back and design this crazy component. More often, they're testing very, very incremental changes. So if they deploy a very incremental change because they're deploying so frequently, the cost of finding that bug so late in the cycle isn't that bad. So because they're constantly doing iterative kind of deployments. Anybody else? No? Cool. Well, thanks, you guys. I hope you enjoyed the talk. If you want some stickers, let me or some of my coworkers know. So we got some sweet stickers.